Quantum technology promises to be as transformational in the 21st century as harnessing electricity was in the 19th. And at Q-CTRL, we are pioneers in the discipline of quantum control engineering, looking to make this field useful.
And my research centers on using the very precise control of quantum systems to test some of the most fundamental questions in our universe, such as what sorts of new physics might lie beyond what we've already discovered.
Fundamental challenge facing quantum technology is decoherence and error, the instability of hardware against interference from the world around it. This is the Achilles heel of this technology.
We're part of a collaboration called the MAGIS 100 collaboration, which is building a 100-meter tall atom interferometry experiment at a Fermi National Accelerator Laboratory. There can be little errors or infidelities that build up. These can magnify into large losses or systematic errors that could be problematic for the measurements.
We really lead the application of quantum control to quantum technologies. We've demonstrated that you can use quantum control techniques to get a factor of 1,000 improvement to quantum computing performance. And similarly, we've shown that you can boost the sensitivity of quantum sensors when deployed in the real world by a factor of 100.
Boulder Opal is Q-CTRL's flagship quantum control infrastructure software suite. It's designed for real research experts who are looking to get the most out of their hardware or to solve some of the hardest challenges in numerical and theoretical research in quantum computing, quantum sensing, and quantum technology more broadly.
The kind of benefit that Boulder Opal and optimal quantum control can give has the potential to make order of magnitude level improvements in the kind of sensitivity we can achieve in our experiments, which could have really a dramatic impact in how well we can search for dark matter, how sensitively we could ultimately hope to search for gravitational waves.
It provides a wide range of techniques that allow you to characterize your hardware, design new controls that allow you to get improved performance, and then characterize the performance of those new controls.
I found working with the Q-CTRL team to be a lot of fun. The researchers there are really interested in the kind of physics we're doing, and they're interested in learning about our very specific applications. That they often take the time to schedule meetings about us to learn about what our needs are and how they can best help adapt their platform. I would recommend Boulder Opal for my peers. I found it to be very useful, and my group has found it to be a very valuable tool so far.